Hi, my name is Teralis Rios, and we're going to be starting with the presentation of the final project, PCL, Ladder Logic, Design, Printing, Automation, Station Automation. For the table of content, we're going to be starting with the introduction, the process description, the CAD design, then the I/O table, timing diagram, ladder logic diagram, the simulation steps, and the conclusion. For the introduction, the project focuses on the design and simulation of a PCL control printing station used to apply logo to parts as they move along in the assembly line. When a part is detected by identification sensor, the system activates a clamp to hold the part in place for 10 seconds. During this time, the thermoset ink is applied for the first 2 seconds using a spray output, followed by an 8-second heating process to cure the ink. To maintain the production control, the system is programmed to automatically stop after 20 parts. An operator must then reset the system to resume operation. The project includes a development of an I/O table, a timing diagram, and a ladder logic program using Logic Pro 500, which is going to be simulated to verify the correct sequence, timing accuracy, and reliability of the system operation. Moving to the process description, a new printer station was added to the manufacturing line to apply a logo to each part. When the part arrives, the sensor detects it, the clamp output activates for 10 seconds, it holds the part in place. Then it has 2 seconds of spray of ink, 8 seconds of heating output ink. After 10 seconds, it releases the part, continuing along. After 20 parts of process, the automation line stops, and then the operator must press the reset to restart the process. As mentioned, here is the layout sketch of the CAD design. Here you're going to see the reset button, the ID sensor, the guard, the clamp, the process where it sprays and it heats, and the PLC. The CAD shows the entire printing station. It's a conceptual layout of the conveyor, identifying the sensor, the clamp, the heated, and the PLC cabinet. Moving to the I/O table, here we're going to see the device, the type, the address, and the function. For the device part sensor tag, we see that it detects the part at the printing station. Then we have the reset button that the operator resets to clear counting and enables the system. The clamp is an output, and it's a clamp actuator output that holds the part during the full of 10 seconds cycle. Then it comes the spray, that's the other output, that it's ink spray output on during 2 seconds of the cycle. And then the heat, that is the output on for 8 seconds of the cycle. Then the line runs the conveyor and it turns off after 20 parts are processed. The system enable, it's an internal bit that enables the process to complete 20 parts, and then the end of the cycle, it indicates after tuning the 20 parts, it indicates an active station cycle. Then the clamp timer goes for 10 seconds. The spray timer has 2 seconds. The heat timer, it has 8 seconds. And then it counts the parts that it ensures that you completed the 20 parts. For the timing table, it shows how the printer station operates during one cycle. When a part is detected, the system starts the cycle and it turns on the clamp, holding the part for 10 seconds. During those first 2 seconds, the spray output turns on to apply the ink. Then the spray turns off, and the heat turns on to apply the 8 seconds to cure. And then after the 10 seconds, the clamp releases and the part is counted, and the system is ready to process the next part. This cycle continues after 20 parts. You're going to see the on and offs, the times that it's on based on the second it has to be in that step, and it continues all the way down from this cycle active after it heats the timer and setting. For the timing table, here you're gonna see the graph where it says that the cycle continues all the way all during all the time, and it has the process stops and the operations where it's processed. Moving to the ladder logic diagram, here you're gonna see the system enable reset and start cycle logic. The figure shows the logic and where it's initiated and controlled the operation of the printing station. The reset is pressed, the counterpart is reset, the system enable allows to launch and the system operates. The system enable remains on after the conveyor moves parts. A part is detected that the system is enabled and the end cycle is launched, indicating that it started and the station is busy. Moving to the figure 2, this is the clamp step, spray, and heat time control. The figure illustrates the time sequence of the printing operation. The end cycle is active. The main clamp starts holding the clamp on for 10 seconds. Then it moves at the same time the timer of the 4 seconds of the spray, and it runs for 2 seconds. And then it presses the ink. The spray timer goes off after it begins for 8 seconds, and then the heat turns on again in order to dry it and ensures that the spray and the heat operations do not overlap in the same process. Moving to the final part is the part counting and the end of the cycle simulation verification. The figure shows that the end of the cycle simulation of the Logic Pro reaches its sun state. It was processed each part counter increments one by one, counting until reaching the value of 20, where the system enables and it turns off and the line runs, stops. The conveyor automatization is also unlatched, releasing the clamp, allowing the system to prepare for the next window of parts. And this is the final of the diagram. For the simulation steps, here you see that as mentioned in the figures below, the process that it followed, it was the reset button, then it moves to the line run where it turns on, then it triggers the part sensor of the cycle. After it triggers the start of the cycle, you see that the clamp turns up for 10 seconds where it holds the part in place, moving for the spray on for 2 seconds and the heat for 8 seconds in order to let it dry. The part counter is confirmed that the cycle has completed, and then it moves to the next part where after 20 cycles, the line stops and it requires a reset button. Finally, moving to the conclusion, the PCL Ladder Logic Development Program is effective. Automates the printing station by coordinating the clamp, the spray, the heat operations with accurate timing. Each part is securely held, correctly printed, properly cured by being released. The use of timers and internal control bits and a partner card ensures reliability. Sequence automatically stops after the line 20 parts. The program printing station ensures proper synchronization of clamping, spraying, heating, and accurate of 10 seconds per part, automatic counting, and stopping after the 20 parts with a simple reset procedure, restarting the process. Overall, the design improves efficiency, precision, and safety of the operation. Thank you.